Hello everyone, my name is Austin Harris, and in this video we are going to be talking about number 9 in our final. Number 9 basically says develop an algorithm for graphs with colored nodes. An example of undirected graph with colored nodes is given below. In this colored graph, G, V, C, E, we assume that there are V number of nodes, C number of colors in the nodes, and E number of links. So for my pseudocode, I found this problem very difficult, but partly because I felt like the book kind of had some more vague pseudocode. But let's go over my pseudocode. I have it on the left page here. So first we'll go over the color destruct algorithm. So first we set S equal to 0, just like the regular algorithm. Then we initialized Q, where Q equals V minus S. Always remember that. And here we're gonna set up a set. The set contains 3 name references. So these name references they contain, for example, blue, red, and black. Given that the source node would be yellow. So it's always going to be initialized with the 3 opposite color name references that of the source vertices, and then also given a vertices. Given a color, for it will return the shortest, or what is known at the current moment as the shortest color node away from the source vertices. So if we give it, for example, blue, it'll return the current node that we have stored for that's closest to the source for the color blue. So then we have Q is not equal to 0. And then we extract min from the book. Actually works great here because our edges still have weights 0 and 1, and zeros are going to be evaluated or relaxed first because they are, if you have an edge to a color that of the source node of your single source, of your source, then it's a 0 as mentioned in the problem. So it's going to go there first. Then we initialize set S, or excuse me, we add U into set S, and then we say for each vertex that's adjacent to U, we call the relax method. Now we pass the CSD set in because that's where most of our work is done. So here's the color relax, and the first part of relax is very similar to what we have for the regular node. We have if v.d is greater than u.d plus the weight of the edge wuv, then v.d is equal to u.d plus the weight wuv. So then we store the predecessor, and now we get into kind of the new part of the algorithm. So we say if v.color equals one of the opposite colors or the different colors of the single source, the source vertices. If that is true, then what we want to do is we want to grab the the vertices that we currently have for the same color as V that's the closest to the source vertices. Once we do that, we find out here if that our current closest color for V that is closest to our single source, we see if it's closer than V. If it's not closer, if V is closer to our source vertices, we now set V equal to the shortest node to our closest vertices to our of different color of these color to the source vertices. Now we have part B, which says discuss the worst case running time for colored zuccas with color relax. So I wrote in the pseudocode, I showed that a set to store the closed colored nodes given a source node. I believe the worst case is we have to search the entire graph to find the closest different color node, which would give us big O of E, where E is the number of edges in the graph. And then for C, we have for given pseudocode above, I believe the best case running time would be big O of n colors, where n colors is the number of the different colors from the source node. This is because we could find the other three colors on the first three nodes we discover from the source node, and we would also know that there's no possible way we could find a shorter path. That is all for this question. Thanks for watching.